Good morning. Hopefully everybody can hear me all right. Let me know. I actually had a problem getting today's live video here launched. So hopefully everything is sounding okay. I'll get everything loaded up here on the other page. As always, let me know where you're from or where you're watching here. And we'll get started here shortly. We'll give it another minute or so for some other folks to join in. This week it's all about winter weather. We didn't get a good opportunity early on in the whole Getting School segment to talk about it. So here it is, week number 7 in. We are drifting towards spring, or we're in the middle of spring, kind of drifting towards summer. It felt like summer of the weekend. Now we're talking about winter weather, and all of a sudden Mother Nature is trying to cool us down at the same time. So there's actually some real practical lessons to talk about in the weather that's happening this week, and some of the winter weather topics that we're going to be talking about coming up. But again, let me log in. I want to make sure that we're actually broadcasting live and everything's working okay here, as I did have some issues here trying to get started this morning from our end of things from a technology standpoint. Let's see, it looks like the video is live. And let me check the audio here. All right. Again, let me know where you're watching from this morning, and we'll get the comments loaded up here and ready to go. Meanwhile, this is Getting Schooled. This is week number 7. Yep, week number 7. My goodness. We've had a lot of lessons. And by the way, all of them are on our website. Also, if you go to YouTube and look in the 13 ABC account, we've got them all there. And for those that maybe are just watching for the first time today, each week is a different topic. Weather-wise or earth science-wise, the first week we talked about tornadoes, wind, hail, lightning, and safety, so it was all about severe weather. Week number 2 is about earth science, volcanoes, earthquakes, and wildfires. Week number 3, we talked about weather technology. After that, it was how to forecast. We even did a forecasting challenge, talked about space weather, the aurora, meteors, and eclipses. Regional weather was last week, Great Lakes, monsoon, and mountain weather, and it takes us up to today, where we're talking about winter weather, and more specifically, the polar vortex is what we're going to talk about today, which gets a lot of attention in the winter time, and yet the pattern that we're going into in the days ahead isn't really that much different than sometimes what we see during the winter that brings us a lot of cold air, hence the reason it's going to be quite chilly compared to average. We'll also talk about snow today. Tomorrow, it's all about blizzards and thunder snow, so that is some exciting stuff. And Wednesday, we'll talk about sleet and ice storms, and why I think it's one of the more interesting types of winter weather. It's certainly one of the, if not the most destructive types. And then next week, it's all about world weather. And to give you guys kind of an idea of what I mean by that, on Monday, we'll talk about climate. We'll talk about the atmosphere. We're going to be talking about, on Tuesday, El Nino, and then a bunch of Toledo weather stories. If you think that we've had maybe some extreme weather events in your lifetime, just wait until you hear some of what's happened in the past around here. And then the last week after that will be all about summer, changing seasons, hurricanes, extreme heat, and all of that. So we'll go ahead and get started. So again, today, Polar Vortex is what we're chatting about. So let me go over to the touch screen here, and I'll walk you through what's going on with it. And it has a lot to do with why this past year, this past winter, we really didn't have a whole lot of snow at all. So let's go ahead and get started here. This right here is what we call a weak polar vortex. And the temperatures on the map, where you see the blue and the purples right across our area, most of the United States, that is some significantly cold air up into Alaska and Canada, North Pole. There's some seriously warm air compared to average that ends up moving in there. So essentially what happens is that the polar vortex, and I'll explain this more later, when it's really weak, it essentially kind of wobbles away from its home. Its home is where Santa Claus lives. It's the North Pole. It's way up here on the top of the earth. That's where that polar vortex likes to live. It's essentially, it's not a big storm system, but it is a circulation in the very high upper parts of the atmosphere where the weather is located. And there's a lot of cold air aloft that's associated with it, but it also is generally where you see some cold weather outbreaks that happen near the surface. So if you look at the globe as a whole, a weak polar vortex means that this area of low pressure aloft, so we'll put it right up here where the X is in the northern part of the hemisphere, it likes to wobble all over the place. In fact, it kind of splits and breaks into a couple different pieces, and it might come down towards the United States. It goes off towards parts of Russia and Siberia. It might branch off here. As it does, it allows warm air to basically move right into the northern parts of the globe, since the North Pole, and it pushes out the cold air and it comes right towards our direction. So this is a weak polar vortex. A strong polar vortex sounds worse, but it's actually what leads to warm weather. It's the reason we had such a warm and not a very harsh winter at all. So this is a look at the upper parts of the globe. There's a lot going on here, but I'm going to walk you through it. I'm going to draw in a circle where we're at first. You see that little yellow circle that I just drew in? There's an arrow pointing to it too. This is Toledo. That's northwest Ohio, southeast Michigan. And we're looking at these brighter colors here with some lines, like there's one right through here that goes through the United States. There's another one in the southern part of the United States. But you can kind of follow this around and all the way around the globe. This is the jet stream that's located across the entire world. So it's not just here at home that we have the jet stream winds, it's everywhere. And we're going to talk more about the jet stream next week in world weather. This is kind of a little preview, but this has a big impact on where that polar vortex is at. In this case, this is what we describe as a weak polar vortex. So where is it? Well, it's in pieces. There's a piece right here. I'll circle it in. There's a piece still close to the North Pole, and then there's a piece here that is slid down into parts of Canada, pretty close to home. And so there's this ridge out to the west. What that means is basically you've got warm air that's been able to push all the way through Alaska. It's basically been able to get right up into where the North Pole is, and it's pushed out that cold air. So that warm air gets up to the North Pole, pushes it out. Santa Claus gets a break. Not that he can wear shorts, it's probably still 0 degrees up there, but for us, it becomes much colder. Alaska will be warmer than us in the wintertime than what will be when this happens. You get this really amplified, wavy jet stream that happens, and it leads to some really wild winter weather here. A lot of snow and a lot of cold air, more so than anything else. I want to show you what happened this past winter. This is not what happened at all, basically at any point during the winter season. In fact, this was taken back in the year 2013 to 2014. It may be hard to read what is wrote on there, but this was a really big winter. Of course, now we're going back 6 years, but that was our snowfall record. We had over 86 inches of snow that year, and we had big blasts of cold air right after another. And the same thing happened the year after. In 2014, 2015, the same pattern set up, and we got blast after blast after blast of cold air. It was remarkable. This is what happened this past year. This is actually back on February 24th. It wasn't that long ago. And so the date's here towards the top of the screen, but more importantly, whoa, don't want to go there. Let me back up here. So more importantly, what we're looking at is that this polar vortex is right here. This is locked in right over the North Pole. And it is not moving. It was a strong polar vortex, and every area in blue is not just cold, but it's extremely cold. It's much colder than normal. And look how it's just locked in right at the North Pole, and everywhere surrounding it in the northern parts of the hemisphere. Nowhere does this even get into the United States except Alaska. And this was the case. You can see how cold it was in Alaska, remarkably cold there. So cold that Fairbanks, Alaska, I think they went like a 40 or 45 day stretch, and they only got above 0 like 2 days out of that entire stretch. We're talking, I mean, they're normally cold in the wintertime, but this was ridiculous. The average temperature was like 10, 20 below, or the average high temperature was like 10, 15 below 0. Remarkably cold. There were days where they're 40, 50, 55 below 0 this past winter. But notice where we're at. Everywhere in the United States, this is warm weather. Because it was so locked in, this jet stream was so strong on the outer edge of this that it was almost like this brick wall, right, that was protecting the rest of the northern hemisphere from that cold air leaving. So it's cold all through this area. That polar vortex is really strong stuff because that jet stream, because it's so strong, the winds in the jet stream is so strong around it that those winds are just circulating around it, but it's not allowing any of that to move down to the United States. And so as a result, we were warm all across the United States except for Alaska. That was a whole different story. Europe over here was warm. Russia and Siberia, for the most part, was warm. Japan was warm. It seems like where everybody was living, it was really warm, except for Santa Claus and northern Canada and Alaska. So Alaska, northern Canada, and here's your polar vortex. This was one of the strongest polar vortex ever recorded here on the records that we've got, anyways, by looking at these observations, which for us meant that we had one of the weaker winters that we've had in quite some time because this pattern never broke down. So a lot of times you hear the scary term polar vortex, and that means cold air, or even sometimes maybe you hear a weather report says a strong polar vortex is invading the United States. Well, that's not right. That's wrong. A strong polar vortex means that this thing is not going anywhere, and it's locked up right into the northern part of the world, and it's not moving. It's like it's set in concrete. It just isn't going to allow that cold air to get away from the North Pole or Canada to move down. A weak polar vortex means this thing is, the winds around it have weakened significantly, and this thing is, the warm air tries to move in, the polar vortex breaks into little pieces all over the place, and that's when the cold air begins to move down into parts of Europe and Siberia and Russia and right into the United States right overhead. That's not the pattern that we had this past winter, but that's what it means. A weak polar vortex means lots and lots of cold air. All right, let's talk about snowfall. There's some ingredients in place here for you to even get snow. You have to have this in place. We talked a lot about thunderstorms and the ingredients you have to have for severe weather and storms in general. But when it comes to snowfall, there's a lot of things going on here too. It's got to be cold enough for that snow. If it isn't cold enough, it isn't going to happen. There's got to be liquid precipitation, right? It kind of makes sense. You got to have moisture and you got to have enough cold air. And then if you've got all that and you've got the conditions right for snow, now you have to figure out how much snow is actually going to fall. You got to know how heavy or how fluffy that snow is. So is it a good snow for making a snowman or is it not? And if you can't answer that as a forecaster, you're not going to get the snowfall forecast right. Because a heavy snowfall, one that is really wet, and you can make a snowman really easily, 1 inch of liquid equals 10 inches of snowfall. That is a lot. But if it's a fluffy snow, like skiers love up in the mountains, real dry, fluffy snow, 1 inch of liquid equals 20 inches of snowfall. So a little bit of moisture equals a lot when it comes to fluffy snow. Heavy snow, it's still a lot, it's just not nearly as much. But that's a factor of off by 2. So think about it, if we're forecasting 6 inches of snowfall, and we've got 0.6 of an inch of liquid, if it's a fluffy snow, we're going to end up with a foot, not 6 inches. So that's a factor of 2. It's really important when we're forecasting to know how wet and how fluffy that snowfall is going to be, or else we're not going to get the forecast right at all. So it's a big thing. Has a lot of importance. Now, if you were watching last week when I was talking about mountain weather, I showed you this map and I showed you how the mountains end up with a lot of snowfall. You can see the white and the purples here. Generally, that's where you've got a lot of mountain ranges, because those mountain ranges force that cold, moist air to go up into the atmosphere, condense, it forms clouds, and eventually forms snowfall. But also downwind of the Great Lakes, we talked about that. That was also last week, it was a week ago. We talked about how the Great Lakes, downwind of them, you get a lot of snowfall. This is a map of the United States. Why does Florida and Texas, southern Texas, does that not get a whole lot of snowfall? Let me know. Write the answer down there. Why do you think that they don't get a whole lot of snowfall? Wait for some of those answers to come in here. But let's go and take a look here at where we're at in northern Ohio. We're kind of in this purple range right here, and that says 24 to 36 inches of snowfall. We're kind of on that line to the other purple line, which is 36 to 48. We get about 37 inches of snowfall in a given year. So we're in a pretty good spot where we do get quite a bit of snowfall. We don't get the extra heavy stuff like they get, again, downwind of the Great Lakes or like they get in the mountains. But outside of that, we do get a fair amount here, end up with about 3 feet of snow. If none of the snow were to melt over the entire winter, we'd end up with about 3 feet. So why does Texas, Louisiana, and Florida not get a whole lot of snow? They're down here by 0 or just a dusting of snow. Well, it's because they're too warm. You know, they don't have the ingredients here in place. They've got to be a little bit on the colder side to get those ingredients to be in place more often for us. So again, you got to have those right ingredients together at the right time. Talking about, when it comes to the polar vortex, the thing that it does, when it's weaker and it kind of wobbles away from the North Pole, as it does bring cold air down to the United States more often, and you do end up getting more snowfall. At least we typically do. Sometimes it's just cold and dry, depending on the pattern, but that is certainly an important ingredient here also. So yeah, a lot of you typing in, it's too warm, it's too hot, you bet. Yeah, if you've been down to Florida, even in the wintertime, you know it can get quite warm down that way. So it's something definitely to be aware of, and it just depends on where you're at across the country also. So let's go ahead and a couple more things, and we'll get to questions here. And I know there are some questions already coming in, but I talked about heavy snow, really wet snow, and fluffy snow, right? Well, the same amount of snowfall has much different weight to it. Even that snowfall that we got, that real sloppy, slushy April snow just a few weeks back, it was real heavy. There wasn't a ton of it that stuck, but if you were to go out there, it made a snowman real easy, and it was real heavy stuff, opposed to what we might get in the middle of January, where it just kind of blows all over the place. Well, the weight is drastically different here with some of that. So just depending on where you're at for us. So, all right, so I showed you a little different snow ratio. This has got 10 to 1, 15 to 1. For us, sometimes it can be 20 to 1, depending on how fluffy it is. But there's different weights with it. The snow that's a little bit wetter, it's better for a snowman. Well, that leads to more and more weight, which means it's a lot more if you're trying to shovel it. So essentially, and behind me, unfortunately, I didn't plan this graphic out real well. It says fluffy snow, normal snow, and wet snow. The wet snow would be like the real heavy, slushy stuff that we had back in April. And if we would have had a lot of it, you can see the difference here. This is a foot of snow on a 1,500 square foot roof, which is relatively an average roof size. But if we were to get a foot of snow and it was real fluffy stuff, it would be like throwing a whole truck or a vehicle on top of your roof. That's how much weight can add up with that snowfall. If it was a normal snow, it would be like throwing 2 vehicles on top of your roof. And if it was a heavy, wet, slushy snow and got a foot of it, which does not happen very often. Usually if we get a foot of snow, it's more in that normal category. But it would be like throwing 3 trucks on top of your roof. And I mentioned this with the mountain weather last week, but sometimes if you go into the mountains, you see the roof is kind of shaped like this versus more like this here. And if you go down south, the roof is a little bit flatter usually. Well, there's a reason why. Usually in climates that get more snow, the roof has more of a pitch to it, which is more angled straight up. And that's because the snow doesn't accumulate nearly as easy. It starts to fall and then eventually it's too heavy and it slides right off the roof. And that helps protect it, because if you get in these spots and get 1, 2, 3, 4 feet of snow, like maybe you get in the UP of Michigan or out in the mountainous areas, you could end up getting too much weight and it could collapse a roof. But if it's more of a pitch like that, it ends up sliding right off of it. So that's a lot of weight kind of getting thrown on top of the roof. I worked down in West Virginia for about a year and a half. And when I was there, we were in the mountains there, and we got a decent amount of snow depending on what mountainside you're on, if you're on the right side. But there was a big legendary storm that came through there in 1998. And since that storm went through, there's another one that wasn't too far from it. But this storm, it was actually predicted there to be like a rain-snow mix, because it was going to be about 35 degrees. It seemed like it was probably going to be a little too warm to really get snow to accumulate. Well, the temperature was just a couple degrees colder, and people ended up waking up the next morning, not with a rain-snow mix, but they ended up having a couple feet of snow on the ground, and it was snowing heavily. They ended up with 3 feet of snow. But it wasn't 3 feet of like normal snow or fluffy snow. It was heavy, wet, slushy snow. And some of those roofs started to collapse. There was a Kroger down that way in 1998. The snow piled up on the roof. It was so heavy. It held it, but then a couple days later, there was more rain that fell. Well, the snow absorbed the rain, so now it's even more weight. And then it snowed on top of it again quite a bit. And so they ended up with not like 3 vehicles on a roof in that size. They ended up with probably the equivalent of like 5 or 6 vehicles. And then they had much more because it was spread out over a large area. Well, that roof ended up collapsing. And there were some others along like it too. So the snow does have a lot of weight to it, depending on if it's wet or slushy or what the deal is. Now, this is showing if you have we hardly ever get 24 inches of snow here. But if you were to get 24 inches of snow, basically you got to double all the weight. So look at that heavy, wet, slushy snow, and you see all those cars on top of the roof. That's a lot of weight. That doesn't do a whole lot of good. The other thing, too, is that this past winter, we really didn't have a whole lot of ice development on Lake Erie. It never got to this point. 2 inches or less, it was never safe. In fact, a lot of folks say ice is never safe, and I would never recommend going out on it. But some folks do. Some ice fishermen do. Back when we ended up having that really big polar vortex that I was showing you back in 2013, 2014, we had ice in some cases up to 18 inches thick on Lake Erie, which was a remarkably different scenario than what we've had this past winter, and that affects everything too. But so in that cases, you did have some folks going out there on snowmobiles and so forth, and this year it was open water the entire time. Talking about the difference between having a polar vortex pattern persistent through a lot of the winter and not having one at all. So a weak polar vortex versus strong polar vortex. So I'll go ahead and get to the questions here. I'll try to get caught up on some of the questions that have already come in first. But if you got a question, go ahead and ask it. Again, it can be related to winter weather. It could be related to anything that we've talked about up to this point, or something else that's just on your mind weather-wise. We'll try to get to that. And again, tomorrow, we're going to talk about blizzards and thunder snow. Quite a topic to talk about tomorrow. Some pretty interesting stuff. Let's see here. What do we got so far? All right. Angela asking, will that affect the Northern Lights show? And this was asked earlier for us. Not Angela. If I'll answer this based off of what I think that you're asking here, but if I don't answer it correctly, just ask again. If you're asking about the polar vortex and if that'll have any impact on the Northern Lights show, the answer is no. None of that would affect the Northern Lights, but if there's clouds around, obviously you wouldn't be able to see it. And sometimes the polar vortex the interaction with that cold air and a strong front that may come through can lead to clouds and snow and storm systems in general, but it doesn't actually have any impacts on the Northern Lights. If you have more clouds, then obviously it would block that out. If that's not what you were asking about, go ahead and ask once again and clarify it, and I'll answer it better. Angie is saying, does this vortex have anything to do with solar flares and polar reversal we are experiencing? Just curious. No, it doesn't have anything to do with that. This is a totally separate thing. Polar vortex was one of those things where meteorologists occasionally talked about it before 2013, 2014. I remember a lot of us don't even like talking about it too much anymore because once it blew up, once that term, it seemed like it was a new term that was thrown out there. In all reality, meteorologists have been talking about the polar vortex as a real thing, a real meteorological thing that's been taking place for decades. I mean, we're talking 100 years, maybe it's longer than that. I'd have to go back and look at the specific date, but a long, long time. And that term never really caught fire, caught on. I remember being in here several years ago when we had the polar vortex coming down. We had 2 big snowstorms in a row. This was the first week of 2014. It was one of the craziest winter weather weeks that we've had here, period, on the record books. I'm not saying it was the worst, but it was probably a top 5 week at the very least. And once we had this polar vortex come down, I was mentioning it and describing what it was and everything else. And about a day later, it caught on fire where the national media, like on ABC News Tonight and that type of thing, they were talking about it, and it just caught on all over the place. And it wasn't being explained right. I mentioned, again, a lot of times you may hear the term a strong polar vortex is coming in or something along those lines. That's not correct. That's the wrong way of describing that science. So it frustrated me, and it frustrated a lot of other scientists and meteorologists in general, just because it wasn't really wasn't the correct way of explaining what was happening with it. But that term's been around for a very long time, and as it's been around for a very long time, it's completely separate from any polar reversal or magnetic reversal or whatever that we're talking about here. The solar flares doesn't have anything to do with that either. So it is totally different here than what's going on. Angie also asking, I remember a few years back walking up to ice all over everything and the sound of our roof creaking and no power. I think we lost power for almost a week, maybe 7 or 8 years ago. It was an ice storm though, not snow alone. Yes, maybe, see, 2010, 2011, there were ice storms. In fact, coming up on Wednesday, we're going to talk much more specifically about that, but we've had some bigger ones in the past. And I'll tell you what, ice, and it depends on where you're at too, Angie, because there was also a couple ice storms that we've had in our southern Michigan counties that didn't really impact areas Toledo and southward also. So it really depends on where you're at. Saying 2013, Yeah, it depends on where you're at. It could have been 2013, depending on location, because we did have some ice storms during that year, but it affected folks differently. Courtney Schultz saying, can there be a sand blizzard? Interesting. I haven't really thought of that one. I will say, you want to see a sand blizzard, head out to, if there's some snow, but, well, regardless, basically if it's cold enough and the winds are whipping hard enough. Coming off of Lake Michigan, they've got some sand dunes there, stretching from northern Indiana, going all the way up into Michigan. There's a pretty large stretch there of sand dunes, depending on where you're at. Warren Dunes, Indiana Dunes, the Indiana National Lakeshore, actually National Park now. They just classified it as a national park. But anywhere along that stretch, there's a lot of sand there. And I'll tell you what, when those winds come out of the north and they get howling right off of Lake Michigan, they are at blizzard material a lot of times, and there's snow drifting all over the place too. But not only is there snow drifting all over the place, there's sand drifting all over the place. So while it isn't actually classified as a sand blizzard, and I haven't actually heard that term before, that's the closest thing that I've experienced to it, is just seeing drifting snow and sand all kind of mixing together, almost like a big sand art project with the swirls that is with it. I'll give it another 20 seconds, another 30 seconds or so. If there's any other questions out there that I haven't answered, let me know. Or, of course, you can hold on to it, and we'll get to it tomorrow. Again, tomorrow we're talking about blizzards and thunder snow. And then coming up on Wednesday, we'll talk about ice storms, which is a fascinating deal. And I'll tell you about the worst winter storm that I've ever been a part of. And I may have mentioned this briefly in one of the other Getting Schooled sessions, but the worst that I've been a part of, and we will talk more about this storm in particular, was in 2009. It's been more than 10 years ago now, and it was when I was working in Arkansas. I thought when I was going to move to Arkansas that I could almost kind of lay back and take the winter off, that they're not going to have a whole lot of winter weather. I was wrong. They don't have nearly as much winter weather as what we have here, but when they get a big storm down there, at least in the time that I was there, it was nasty. And in 2009, there was an ice storm down that way that went right through northern Arkansas, started in northern Oklahoma, went all the way through Kentucky. And it is classified as one of the top 5 worst ice storms to ever hit America, ever. And it was absolutely catastrophic. There were people without a power in spots up to 3 weeks. Wow, unbelievable with that storm. So anyways, we'll talk all about that. That's Wednesday, tomorrow, blizzards and thunder snow. Let's see if there's any more comments here. Let's see. So Bobby's saying to be more and more often we go from cold weather to wet, cool weather, and then only like a week or two of nice, enjoyable weather in the 70s with some sun, then to hot weather up until the fall months come. What affects this to where we're having less and less enjoyable weather and less and less time frame? I live in Lenawee County in Michigan. I'm going to actually pull up the data that I had. Last year that I tried to actually calculate this very thing that you were talking about on whether things were shifting with that kind of enjoyable time frame in the middle of fall and in the middle of spring with some of those temperatures. And I will say spring and fall are by default or what we call transitionary seasons for a reason, because they fluctuate back and forth. It's always been that way, probably since the beginning of the climate system that we have here in this part of the country. But anyways, let me go back to the data that I have. And shoot, let me see if I can pull over the camera to this graph. I don't know if it'll reach over or not. Let's see. I'm doing the best I can here. So this is the graph showing these are spring days. So March, this is March, April, May, and June. So you've got 4-month time frame there. Boy, that's tough because it looks like the curve there is slightly down. So hopefully that's what it actually looks like. But the number of days that we had, say, back in the late 1800s and 1900s and even through the 1950s, the amount of quote-unquote enjoyable days in the spring has decreased slightly. So that does make sense with what you're saying. It's not a significant drop. It's a very, very small drop. farther down, though, let's see if I can get the camera down this low. That's even tougher. This is in fall, and the amount of enjoyable days in fall actually has gone up very slightly. If you combine both of these data sets, it actually cancels out. But there are some trends that we've noticed here. Let me get the camera back up. But there's been a couple trends that we've noticed. One is that, again, you're probably losing a little bit of enjoyable weather in the spring, but we're making it up in the fall. And there's a little bit more to that, at least in the last 20 to 30 years. But if you be even more specific with that, certainly in the last decade, there seems to be a trend where the seasons are kind of pushed a little bit later. Point in case right now we're dealing with some of the cool weather that's frustrating at times. We went into the winter season, or typically this year was a little different. November was cold, but December was warm. And a lot of times we kind of move into October, November, December, and it's still warm, but kind of still holding on to those fall-like conditions. Winter doesn't want to give up its territory. A lot of the summer heat that we're seeing these spikes in September, and September is almost always warmer than average, it seems like now, and that kind of holds on to October. And then again, fall kind of holds on a little bit later into winter. That's a definite trend that we've been seeing. The severe weather season's been pushed a little bit later as that cool air doesn't want to leave. So there's a little bit of truth to that. It's kind of hard to prove in numbers, but the condition seems to be improving for fall and decreasing slightly for spring, but we always have these ups and downs every single spring and every single fall, which is pretty common here for us. All right, it looks like that's it for today. I'll go ahead and I'll post this video. We'll get it up on YouTube also, and then tomorrow will be, so if you want to share it and want to watch it later, you can do it that way. But coming up in the next couple days, we'll talk more about thunder, snow, blizzards, and ice storms.